Good morning. So this is a very interesting kinematics problem. One body is in uniform acceleration, and the second body is with uniform motion. That is, it has no acceleration. Now, what we have to do is we have to, graphically represent the difference in the displacement of the two bodies at time t, right? So if you see the four graphs, the first graph, second graph, third graph. Look at the fourth graph. If you look into the fourth graph, the first thing that strikes you that this is a graph of uniform accelerated motion, which is a parabola. But the graph we have to draw is for x1 minus x2. We don't have to draw graph of only x1, which is uniformly accelerated. So this choice is absolutely eliminated. Okay. Let's talk about the maybe the before we even talk about the other graphs, let's do one thing. Let's try to find out the meeting points of the two bodies. So if you see, I've written the equation x1 and x2, and once you write these two, you write x1 minus x2 and put x1 minus x2 is equal to 0. So what you get is two roots when you solve this equation. One root is t is equal to 0, and the second is t is equal to 2u2 by a. Now, if you look into all the options, you do see two roots, but the option number C to me looks a bit awkward. But let's see what happens. Now we know there are two meeting points, and A, B, C all represent two meeting points. But here is a deal on how to decide what is the exact nature of the graph. Now, one of the key tools we have in you know solving kinematics is using calculus to establish a few things. If you remember, we did test of curvature, and you can see my video on test of curvature. It'll give you a sense of what I'm talking about. If you'll try that, I have taken a single derivative of x1 minus x2 and then put it equal to 0, found the t at which dx1 minus x2 by dt is equal to 0. And what I find there is that the double derivative is coming out to be 2a, and a has been given to be a constant acceleration, which I believe means constant positive acceleration. So which means that t is equal to u2 by 2a, which is found by making the slope, you have a minima. Now, if you look into the graphs, what you find is at the graph number A, you have a minima, because the other graphs, if you look into graph number B, that has a maxima, right, in the quadrant 1. But the graph number A has a minima in the quadrant 4. The graph number C, you know, does not tell you about the maxima. It does give you a local maxima, and but that also is a maxima. So the only good choice left is A, and we used two mathematical, tools. One is trying to find out how many places does it meet. Second, using double derivative, the concept of maxima and minima to decide the presence of minima or maxima at a certain place. And that told us that in A, there is a minima existing, and that is what the double derivative also talked about. No other graph has any minima present. Thank you very much.